Welcome to our review on Newton's second law. So previously we've had a look at what happens if the resultant force is zero. Now what we're going to look at is what happens if the resultant force is not zero. And what we can see are a few different effects. It could change the speed of the object, it could change the direction of motion of the object, or it could change both the speed and direction of motion of the object. So because we're talking about the speed or the direction changing, we're talking about an object that is accelerating. So the bit we need to remember is what Newton's second law states. And Newton's second law states that the acceleration the resultant force produces on an object depends on the size of the resultant force and the mass of the object. One thing they could ask you to do in the exam is to carry out calculations about forces. So there's an equation we need to learn, which is force is the mass in kilograms times the acceleration in meters per second squared. Do remember we've got some standard units here to watch out for in the question in case they're asking you to convert. So mass should be in kilograms, time should be in seconds, lengths should be in meters, and when we're talking about a newton, that's a derived unit. So 1 newton is actually 1 kilogram meter per second squared. But that's quite a mouthful, so we tend to just use 1 newton. If we consider an example question then, a lorry has a mass of 8,000 kilograms. What resultant force is needed to produce an acceleration of 2 meters per second squared? First thing to do, as always with our calculation, is highlight, underline, circle or jot down the key values from the question so you don't have to reread the whole thing over and over again. And I've done that in red in the question, as you can see. Then we're going to write down the formula we're using. In this case, force is mass times acceleration. Substitute in our values. 8,000 is our mass times 2 for the acceleration. Plug that into your calculator, and that gives us the answer of 16,000 newtons. And remember, always write down the working in the answer space, not just the answer. Another style of question they could ask us is this one. Calculate the acceleration of a car if the force due to the engine is 1,000 newtons and drag force and friction equals 600 newtons. The mass of the car is 800 kilograms. First thing, as always, highlight, underline, circle or jot down those key numbers from the question itself, and I've done that in red as usual. Then we need to calculate the resultant force first of all, because in our question there we've got forces acting in opposite directions. So we've got 1,000 newtons in one direction, and in the opposite direction we've got 600 newtons. So when we work out our resultant force, we have a 400 Newton resultant force. Then we need to use our formula and substitute in, but we have to rearrange first of all, because we're working out the acceleration this time, so it will be acceleration is force divided by mass. Substitute in our values, 400 divided by 800 gives us the acceleration of 0.5 meters per second squared. And as always, remember to write down every step of your working in the answer space so that even if you have a calculator issue at the end, you will get some of the marks, not just 0. One of the things they could ask you about is how to carry out experiments to investigate things like Newton's second law. So you've probably done experiments using the trolleys and masses to do this. And there are a couple of things we need to bear in mind about these experiments. First of all, we need to compensate for friction. So the way that we actually compensate the ramp for friction is by raising the ramp to an angle until the trolley moves down at a steady speed without accelerating. Second thing to consider is how we could remove the issues with us doing the timing with a stopwatch, and the best way to do that is to use a light gate to record the time. The last thing we need to consider then is how objects are able to move in a circle. So when we've got our object moving in a circle at a constant speed, we still say it is accelerating. Even though it's going at a constant speed, its direction is constantly changing, and that is acceleration. To enable that object to actually travel in a circle, we've got to have a force directed towards the centre of the circle that acts on the object. Hopefully at the end of this video you can recall Newton's second law. You can apply Newton's second law in calculations relating forces, masses and accelerations. You can recall the equation for acceleration, and you can explain how force, mass and acceleration are related.